Onchocerca, or river blindness as it is commonly known, is one of the neglected tropical diseases with great impact on health for people in Africa, some parts of Latin America, and the Yemen Peninsula. There is the need for a proper, specific and sensitive differential diagnosis for this disease. The parasite is a worm called Onchocerca volvulus. Humans get the infection through the bites of these black flies. So to determine the level of infection, these flies are caught, dissected to detect these parasites. However, this methodology is quite tedious, time-consuming, and sometimes the method is not sufficient for proper identification of these worms. Again, we have PCR techniques which are used to detect parasite DNA in these flies. The cattle parasite and the human parasite are so closely related that the PCR biomarker use cannot differentiate between the two. Hence, there's been a need for a proper method that can be used to differentiate these two parasites. Our findings in this study had been the identification of a proper biomarker for specific detection of Onchocerca volvulus in the black fly. The second big finding in this study was the incorporation of a very simple detection platform for the detection of these parasites. We incorporated a dye system, which is just a colorimetric system that upon reaction and upon change of color, you are able to determine whether your test is positive or is negative. With the color change procedure, we compared two different color change dyes, the NEB red and the commercially available naphthol blue reagent. The BSD 2.0 was the enzyme we use for this current study. The assay is based on the LAMP methodology. It's one of the cheapest technologies so far as compared to, let's say, the standard PCR. And what makes it more applicable to resource-poor countries is the fact that it uses just basic equipment. You can either use a LAMP turbidity-based platform, or simply a water bath or any device that can heat up to, let's say, between 60 to 65 degrees. In collaboration with two labs, one in Ghana, one in Cameroon, and the idea is to optimize and have the assay tried in the field conditions.